Welcome to Vision 2222, the podcast where we explore the scientific, technical, social, and human changes that we might see if we were able to travel 2 centuries into the future. We interview leaders in science and technology and experts in business and the humanities to look into the possibilities of the future. Vision 2222 is the brainchild of Mikhail Gladkikh and his co-hosts, Amanda Chadee and myself, John Marsh. I'm an administrator in a leading research university, and I get a ringside seat into the amazing discoveries and new materials that will enable us to thrive in the future. Our guests today are Esteban Montero and Brandon Baylor, authors of the book, A Categorical Defense of Our Future.
My name is Mikhail Gladkikh. I'm your co-host. I'm a technologist, and I specialize in additive manufacturing and everything that is related to the Industrial Revolution 4.0, as people call it. I'm also a science fiction author, and I write in my spare time.
I'm Amanda Chadee, consultant and mentor to early-stage startups in biological and life sciences. I specialize in business development and funding strategies to support early-stage startups in the big leap from lab discoveries to creating and selling valuable commercial products. I'm delighted to introduce Esteban and Brandon as our guest speakers for today's episode of the Vision 2222 podcast. Esteban has diverse experiences in environment and sustainability, process safety, data science, and systems engineering. He started his career as an engineer in the copper mining industry in Chile. It is there that he embarked on his passion for community outreach, founding and directing a magazine about education. He has degrees in civil mining engineering, finance, and systems engineering. Esteban has practiced martial arts for over 30 years. Brandon has held various professional roles around the country working for an energy company. This includes multidisciplinary experiences in safety, operations, engineering, and innovation. He's trained as an engineer and holds a master's degree in engineering and management from MIT. His academic and industrial work dealing with complex systems has propelled him to create effective technologies that integrate systems and decision-making at scale.
Esteban and Brandon are the founders of Holon Computing, a nonprofit foundation that's dedicated to the research and development of a collective computer. In this episode, they refer to that concept as the cat computer.
Their vision and technology are based on all their experiences and ideas described in their first book. They're also working in parallel to publish a second book, specifically about the concept, technology, and story behind the cat computer. Congratulations on your first book, A Categorical Defense of Our Future. We are eager to begin our discussion on the possibilities for our future world. First, both of you, share anything you would like to begin with. Tell us how you both know one another and what is the inspiration behind this first book.
Amanda, this is Esteban. John and Mikhail, thank you so much for doing this, for the opportunity to talk with you today, but for doing this, for helping us all think in a future that seems to be far away, but so important to all of us. So congratulations. I'm inspired by your effort.
Yeah, thank you. This is Brandon, and I just want to say that Esteban and I got to know each other through our professional relationship first in the energy industry. But as we came to know one another, we were able to connect over our shared experiences at MIT, where we both went to school, and the influences there, and all the struggles that we've had really for the last decade working in the front line with some of the most resourceful organizations in the world and struggling to more effectively deal with complexity. And so all that combined experiences was what really inspired us to start writing the book, to help sharpen our ideas and to really converge on our thinking in this space.
So today we want to give our listeners a way to understand and relate to the concepts you described in your book. and apply these new ways of thinking in all our life's experiences, at home, at school, in work, even in politics. And I think to begin our discussion, the first line in chapter 1 is a great way to start. I quote, "The modern world has become complex in ways that make human intuition and existing tools no longer sufficient to navigate it." You introduced the terms systems thinking and systems thinker as a new way to solve complex problems. Can you explain to our listeners exactly what does this mean? And why is it important for us to try to have a new way to organize knowledge and manage complex systems? Can you give examples of can a person become a systems thinker to make decisions in a unified way? And is this in any way different from innovative thinking?
Thanks, Amanda. We hear in all of our lives a lot of concerns around how do we put things together and how do we think about the parts that come together to form a whole, whether that's in our professional lives, whether that's in our personal lives and endeavors. And we think that we use the term systems thinking to help us get a framework to start thinking about what's stopping us from doing that. What's stopping us from putting things together in a more constructive and effective and harmonious way. So we think that it's important to be able to describe what that framework is that we're both trained in and have helped to get to this point. And we also think that one of the ways that, at least for us, where we draw inspiration to think more holistically as think of the system, we call it the beginner's mind, the beginner's mindset. And the challenge is, and maybe Esteban can describe that a little more detail, but it's almost impossible today to think like a beginner and to stay open to future possibilities and innovative ways of thinking. It's challenging to think like that when just to understand what is going on around us in this complex world requires becoming an expert and sort of solidifying and crystallizing assumptions that become very tacit and challenging to overcome. And so we think that to achieve a beginner's mind and to stay open is a key to thinking as a whole and to really appreciate what that means. So I don't know if Esteban, you want to build on that, but that's a key for us in the book.
Thank you, Brandon. Yeah, what I will add is, I don't know you, but in my personal life, I used to think about problems or aspects in kind of separated ways. Like losing weight is one thing, managing my finances is another thing, managing the relationships with my family is another thing. And so we are kind of trained to think about these things as problems that we have to solve, and we have to treat them in a certain way. And I think the modern world has done something incredible, which is it's giving us applications in our phones to do all of that. I actually have an app to try to track what I eat, and another app to manage my calendar and so on. But if you think about it for a little bit even, you will realize that all of those things are connected. The relationship with my family is pretty much entangled with my food and with my finances, and so the reason why we separated it is because it's just too complex to manage it. So we put these labels, and these labels help us address and deal with this complexity that is so overwhelming. And as Brandon was saying, kind of systems thinking is kind of the removal of those labels, so we can think about our lives in an integrated way. And I like your question because it's like you can start from your personal life thinking and getting trained to reason in this way, and then go to your job and think about your corporation, especially if it's a big global corporation that is magnified in orders of magnitude. I mean, there are teams of hundreds of people specialized in one aspect of the corporation, and then there is another team that is specialized in another aspect, and that is what we are trying to reimagine. And in the book, and why we decided to write this book together, we think that this is the core of many challenges that we will face in the future.
Yeah, and I agree. I think, from what you both said, just removing the labels is such an important point to consider, and trying to understand that everything is connected in some way. And, from your example, Esteban, with like trying to lose weight, or even, if you're trying to do a proper skincare, or there's so many things in our lives that can, if we remove the labels and try to think of it holistically, it's actually mind-opening when you think of how you can address these problems. So even in today, with AI and big data and connecting even medicine and information systems, we have these large amounts of data being thrown at us, and the information is complex. For most of us, our minds have been trained to organize knowledge in subsets based on, whatever defining criteria is needed. There is an effort currently to really keep things simple. And many companies have specialized departments and they hire people with specialized backgrounds. For example, hospitals would hire specific doctors. You call these knowledge subsets in your book silos, which refers to freestanding grain silos on a farm. I feel like reduction, which is basically a way to explain a complex system by breaking it down into smaller parts. So that's the definition. One of the main approaches that most of us use to process information, to understand it, to draw connections. And, I believe that most people would generally feel secure knowing that a person is specialized in his or her profession, especially in medicine. So, from your book, do you think that silos and this reductionist approach should be fully eliminated? Like, we shouldn't think like this anymore? Because I personally think that, a solutions to silos is just effective collaboration. Some companies, institutions encourage collaboration. Why is this not sufficient?
Thanks, Amanda. Yeah, so I think if you look around, it's pretty evident everywhere the struggles that we face to work together. Even I think just this week, at the time of recording, there was a aviation shutdown across the country just this week because of a system sort of challenge, and had to ground all the planes for part of the day. And like, we can cite hundreds and hundreds of those examples where it's not sufficient, the ways that we're working together and the ways that we're trying to collaborate today. And so we think that even interrogating deeper what it means to collaborate in this question is useful, because what we've found in our experience is that collaboration, the ways we go about it today, quickly becomes impossible. And we see that problem with agile ways of thinking in our business world, and specifically in product and technology development. These sort of incremental mechanisms, for collaborating may work on a scale of one person or a small team, but our question and our quest to improve managing complexities beyond that, because we're talking about a scale that's much greater than that. The mechanisms for one person is different than 1,000, and so on. So I think what we're advocating for is a new type of coordination altogether, and it really exceeds the question. Esteban, do you want to add on to that?
Yeah, I think the confusing part is that is both. It is important to recognize that it is working. We have successful companies, and most of the time things go right. And so you are correct to say that in the situations in where we are kind of stitching the parts manually by collaborating, it's working most of the time. The problem that we see is that more and more it's becoming important to examine those extreme cases, those borders of the scenarios. And I think collaboration, as Brandon says, breaks down at that scale. So in order to examine those rare events or those situations that are becoming actually quite common, if you think about it at a global scale, you get tricked by your mind to believe that it's possible to take that scale. But if you actually put some math together, you realize that the combination of things that have to happen, the combination of meetings and the number of interactions that have to happen to make that collaboration happen is unfeasible. Let's don't say it's impossible, but it's a really, really large number. So the answer to that is that some people believe that computers are going to become really, really fast. So it doesn't really matter, because if we have near infinite combinations, we can examine them with a computer that is super, super fast, and so problem solved. We don't believe that that is the solution. We believe that in order for computers to understand scenarios, it's not just a problem of computation of scenarios, but it's also a capacity to reason about the meaning of those scenarios. And the word meaning is what throws everything out of the board, because our machines today, our computers, are not designed to contain meaning. If you look at the information theory by Claude Shannon, his original paper, he says it very clearly. Meaning is irrelevant for the engineering problem. Zeros and ones don't contain meaning. So we are connecting individuals' machine collectively, but that doesn't create an emergent property of collaboration in an effective way. So that's why we think it's not effective at that scale. We think that most of the time it is, as you say, but we have to consider those rare events because they're becoming more and more common.
So it's really down to the scale because of, making decisions on such a large scale. Collaboration would have weak points. Is that sort of a correct interpretation?
That is one. I think that, yes, thank you for clarifying that. I think the other part that I will say is that a little bit of what Brandon was saying. Once you get to mechanisms of collaboration, you end up kind of solidifying the silos. You say, well, if you think about a hospital, like the team that is in surgery and the team that is preventive and the team that is the staff running the show, if those mechanisms can collaborate effectively, then everything is fine. But what collaboration forgets to do is to think about what else can happen. What are the unknowns? And so in order to collaborate, you have to know who is going to collaborate in that meeting. And that is not, you cannot invite somebody that you don't know that you have to invite. So that thinking about collaboration breaks down. And so that's when you have to start removing the labels, and then when you kind of get into that fast pace.
Thank you for that clarification. Mikhail?
You mentioned in your book these 6 camps, and that these old ways of thinking are problematic and are a barrier to working and finding solutions in the world of complex systems. Dishonesty with ourselves and others take the form of these 6, as you call them, scams, such as data science or machine learning or problem solving. So the question I have in my mind, these are really the tools that were developed and are used in the context and for the applications they were created for. Would you agree with the statement that yes, these are the tools and we could use them in the approaches in the context for which they've proven to be useful, but they're no longer applicable to the complex behavior and all these different systems and systems of systems actually that you're describing? Or are those tools malicious by nature and should never be used? What's your take on this?
Thanks, Mikhail. I would start by saying that in a lot of cases, what we see are tools that made sense in the technical and philosophical context in which they were created. But I think that context is changing. And in a lot of ways, now we are confused. And what that confusion induces is fear and anxiety and incentives to use them in ways that are dishonest or not transparent. And so I think rather than answering the question around whether they're inherently malicious or bad, we should appreciate just having the awareness to be able to ask that question and point to it and say, this is something we should be asking ourselves every day. And so I think that one of the early motivations for our book and for the thinking that we had was considering things like this on whether objects themselves are evil, or in the context of these tools, as you said, if someone just uses an answer or response like just because I say so as their response, like that can become a shelter for hiding from something and from hiding from complexity and that sort of, again, back to the labels of a binary view of the world. So which is, again, the tools that we came up with using something called set theory, which is sort of the foundation of how we think in a lot of ways. So I think rather than, prescribing and judging whether the tools themselves carry that by nature, I think we should appreciate just having awareness of how do we answer that question.
No, this makes perfect sense. Thank you. Thank you for that. I recently read about machine learning, right? And the conversation was about the fact that with machine learning, because we can predict any outcome if we have enough data. So that was the premise. Then maybe we don't need any science anymore because we could predict any outcome or any complex behavior on a universal scale, or with climate, or with planetary wide events and things like that, with which I completely disagree. I think
Right.
you share my take on that.
Just to add, I think what you said, Brandon, is very important. The tool in itself, and this is kind of the core of the systems thinking and approach that we are advocating for in the book for the future, trying to attribute intrinsic characteristics to tools is kind of missing the point to us. It's like we need to think about tools in context, in how they are used, in how they are envisioned by their creators, and so on. There are many philosophers who talk about the politics of objects, for example. I think you will find maybe I'm sure you're aware of that. There are many examples in systems engineering of tools that have been used in different contexts and produce completely different behaviors. There is a performance artist that I love that we mentioned in the book, Marina Abramovich, and she has two performances in her history as an artist. At the very beginning of her career, she just put a table in front of the audience and put like a marker and a gun and something like a scissor, and told audience you can do whatever you want with them. And I encourage you to look at the experience of that experiment. Like, is a marker evil? Is a scissor? Is a gun? But you see the reaction and how it's used by the people in the performance art, and it's fascinating to see how context changes everything. And so I think that's kind of what inspires us to think about systems for the future. How do we build technologies like machine learning, like you say, for a future and for a context that is helpful to us and not the opposite?
Right. No, thank you for explaining that. And to continue on this topic, in the book, you define the concepts of composition and compcreation as a new way of thinking about complexity and these complex systems. The basis for that is the category theory, and it's a central theme in the book that is the foundation of the solution to prevent us from reducing things, but instead creating or creating those critical systems. And most importantly, to consider how our human experiences play into this complexity and it becoming part of these complex systems as we interact with them, we becoming part of it. So from that perspective, is there any connection between compcreation and the lean startup approach that we hear about in the business, and also design thinking that specifically takes into account human experience with these engineering designs and solutions?
Mikhail, I think it's fascinating that you connect those two things in the question. And so let me tell you my reaction to it. So I was lucky enough to take a class at MIT with the guy who wrote the book in where they actually coined the term lean manufacturing. So lean manufacturing comes from an effort that the US government had to kind of understand what the Japanese were doing, why they were so much more reliable and so cheap. What were they doing? What kind of magic? So they sent these MIT professors to Japan to understand and spend time there observing what Japanese manufacturers were doing. And they came back and they wrote this book that is called The Machine That Changed the World. And in that book, they say they use a lean manufacturing method. What I find fascinating of that is that is an interpretation of what Japanese were doing. In Japan, they don't call it lean. Lean means no waste. It's a very judgy question in my mind.
Right.
Because Japanese call it Toyota manufacturing method. It's very neutral. This is how we do things. This is our craft. This is a process for us to be aware of what the other is doing. It's a process of efficiency. It's a process of understanding, of reconsidering our mistakes. It's a very complicated process. But here we translate it and we say, well, that's too complicated. Let's just call it no waste. Not lean means no waste. That's what they're doing. Let's remove all of the waste. Well, the challenge of that is that you need to know what waste is and what is productive. In some cases, it's obvious, right? But in many, many cases, it's not. Again, like, are tools evil? Well, are tools wasteful? We don't know. I mean, I think that's a really difficult and profound question. And so the way in how I will think about compcreation in contrast to lean is to say, let's don't label it as wasteful or not. Let's think about it in the context of everything else. Let's have that exercise and that discipline to be always thinking about craft and process in a way that is non-label and open to understanding. Now, lean manufacturing is a really successful method, but I think at the same time, it's very hard to think about a startup. If I could know what is wasteful in a startup, well, then I will just focus on that, right? That's the premise. Well, maybe this brings us to, I don't know, machine learning, computers that don't sleep, computers that don't get distracted. Well, what if those are keys of intelligence? What if we as human, by getting distracted, we imagine, by sleeping, we do something that we yet don't understand, but here we are calling it wasteful and trying to make machines that don't do that. So that's kind of what we are promoting. Let's think about it with more humility, with more time, not because we spend 6 months in Japan, we can understand what they're doing. Maybe we can. Maybe we are MIT professors and we are super smart and we just get the thing and let's remove everything else. but let's observe what the Japanese, and by the way, what everyone is doing, and learn from it with an open minded, with a beginner's mind. And I think that's kind of the invitation. It's kind of philosophical, but it touches the technology. In compcreation, we say this is about the emergence of things, and we don't know yet until it happens.
Right. And yes, I share. I think I would agree with what you just said. Where I was going with that is not necessarily from the lean startup approach, which yes, it's based on this lean manufacturing idea applied to startup and business thinking. But the real foundation there is applying scientific method, and applying that scientific method for product market fit, how they call it, and solutions to customer problems. And the idea is that you formulate assumptions, you experiment, and then the concept of the solution start to emerge from all these different things, which include your engineering design, but also the foundation actually is the human experience and what kind of problem they're facing and how we understand it and what is the solution that we could provide.
The only thing that I will add is that if you are in a startup or in any effort and you're building and designing something, I think having even the word lean anchors your mind to, we have been in these agile methodology meetings in where people say focus on the productive, they're very short-term thinking increments of the working methodology. But the challenge is when it's used against you. So when we put labels, those labels become sometimes our enemies. Like in a sense, if I say, let's spend a week exploring this different avenue, that different avenue could become in the future something very productive, something we just don't know. But most likely it will get shut down because it's not directly related, it's not short-term value, it's not, So when it's when thinking is so direct, cause and effect, we disable our capacity to think in more complex ways. We think it's an emergency. We think this is really important because corporations and methodologies of working, like lean manufacturing, are putting a strong emphasis in short-term cause-effect thinking, rapid iterations, short-term thinking, rapid delivery, right?
Yeah, no, I completely agree. And when we start saying, well, we want to be agile, we want to accelerate development, we want to be lean, we want to work faster or do more with less, then the end result is it doesn't lead to true innovation and system thinking, as you said.
After he had listened to the recorded interview, Esteban asked us to add the following to this part of the discussion. Our traditional understanding of science is that it is a way to find truth, exactitude, and precision, and to reduce confusion and complexity by replacing the veil of ignorance with knowledge and systematic reasoning. This way of understanding science pretty much follows Descartes' mind-body dualism that we can associate to Western philosophy. This way of thinking has been essential to achieving the progress and technological development that we enjoy today. In that sense, lean and design thinking have benefited from scientific approach to business and decision-making. But what if the way in which we understand science changes? What if the separation between mind and body, matter and patterns, became less clear as we moved towards more complex and interconnected systems? We believe that businesses and decision makers would benefit from a new understanding of science, one that is more entangled and open to mysticism, to embrace our limited ability to understand everything and partner with nature in a more humble way. In this sense, the relationship with complexity is not anymore about understanding cause and effect, but about harmonizing with everything around us in a way that adapts constantly to an ever-changing context. Our collective computer relies on science and in that sense is comparable to lean and design thinking. The difference is that we are advocating for embracing science in a new way, less exact and more complex, more expansive.
So the next question I have is just to go deeper into the process of system design and comp creation. How would you suggest applying this? And I understand that a lot of it's still theoretical, as in the category theory, but just to illustrate your way of thinking, if you were to apply it to this emergent trends of today with things like metaverse and digital existence or virtualization of things and processes. How do you start thinking about it? How would you apply it, and what are the systems and systems of systems that need to be created?
Thanks, Mikhail. Well, I would start by saying that we see all sorts of trends, like you mentioned, avatars and meta and online identities. I think we have to question the unintended consequences of those things. And so we think that the first step we need to take with composition and comp creation is really going to the first step, and challenging and asking, is there another way? Because what we see is that some of the assumptions around things like avatars and meta, the future, we have this belief that there'll be a portal to some digital world where we humans are limitless. And, somehow our technology leaders have convinced us that we can just simply pick out the best parts of our lives and remove the rest that we don't want, and in a way that disconnects us from our context. And we actually think that there's a lot of things that we need to ask about that and challenge whether there's a new way and another way to connect with the context that we're in, with the present, to connect with nature, to become more aware as a collective. And so the first step to us is really going to the first step. And in the context of computers and as a personal computing device, as a way to take us to these meta fantasy worlds, we want to ask and a challenge, like a computer, is it only just a silicon machine that's based on binary? And, that's step 10. And so step 1 to us is really going all the way back, as we've sort of been alluding to throughout the podcast, and having that beginner's mind to really challenge some of the assumptions around how can we go about technology and the future that we see on the horizon in ways that are more harmonious and constructive. And so, I don't know, Esteban, that's a good segue. You can describe where we're going with that idea, but I think the first step is to really take ourselves all the way back.
Yeah, absolutely. I think if you look at it from a perspective of like the history of technology, like we have early computer explorers like Alan Turing, right, developing the idea that computers should be intelligent. And when you ask, and I think he actually said it like that, intelligence for him was the capacity of a computer to deceive us. So we are literally building technology to deceive us. And if I stop and think about the meaning of that word, and maybe it's because English is my second language, so I think a lot about the meaning of each word because I translate them. I wouldn't find a partner. I wouldn't work with Brandon if his objective was to deceive me. So why are we building technology to deceive us? What is this metric of intelligence? I know a lot of very smart people who are people who I don't want to be associated with. So who said that the pursuit of artificial intelligence is a worthwhile goal? We are blinded in a way by our history because we are already in step 10. We have the computers, very successful. Then we have Claude Shannon, the digital transformation, then the internet, then Apple personal computer. Our lives change. It's so much easier. It's so much better. It's so much exciting. And then here we are in step 100. And now our technologies are saying, well, you don't even need your body. And I don't know you, but it sounds depressing to me. Like that is, first of all, it sounds depressing, and it sounds a future in which I don't want to live. I do want to be connected to my body. I do want to be connected to the ground and where I'm walking and to the air I'm breathing. I don't want to be living in a fantasy, in a 3D world that is only the good parts of my life, because the bad parts of my life are also part of my life. Is what they make them, what they make the good ones good ones. But we seem to lose that. I mean, that sounds like almost like cliché talk or like philosophical gibberish to technologists. We think that there is a future of technology in where that is the core of the architecture of our systems. Technologies that don't pursue intelligence just for the sake of intelligence, but pursue other metrics like awareness. We call it the future of collective awareness. We think computer science should aim to do that. Computers should increase our awareness. If we want to hire a leader in a corporation, we don't look for the smartest person in the room. We look for executives that are aware. Awareness is becoming a really important metric in leaders, in teams, in personal life. So if you have been lucky to practice, I don't know, meditation or other practices like that, or any sport that puts you in a state of flow in your mind, you understand what awareness does to your happiness and to your well-being. So why not aiming towards that as a society and as a technology? We believe that computers can increase that. We call it the collective computer. Our CAD computer technology, our next project, is a computer that departs from Turing's vision of intelligence as the ultimate goal and moves us towards awareness. Departs from Zuckerberg's idea that you can be in a corner in a dark room with a 3D glass, believing that life is perfect, and brings us back to reality, grounds us to nature, connects us to the biological, chemical, physical systems that are all around us. I was a mining engineer, so I know how these minerals that we carry in the computers were mined. It is a huge impact to our world. So I want to live in a future in where machines are more regenerative to our ecosystems, in where machines use materials that are friendlier. So that to us is how compcreation, back to your question, right? How can compcreation be associated to this change? To us is thinking about the whole thing from scratch, beginner's mind, with the new technology. And one more example that we always give is like if you take electric cars are not new. They were invented even before internal combustion engines. And somebody came recently and said, well, now we have new technology, we can revisit that type of car and reimagine it, you know? A very successful car company came from that. So we think we can do the same with computers. We can say, you know what? Silicon-based binary machines that pursued artificial intelligence don't need to be the only way a computer is. And these are really smart people, but we can produce something else. And let's try. And so that's what we are doing in that space. Thank you, Mikhail, for that question.
And thank you for the explanation. And I have to ask this question now. As you talked about the awareness and the role that computers could play in that. So imagine if we create that shared awareness, or we increase our human awareness with the help of this new way of computational device, let's call it this way. Would you include that computational device in the shared experience and the shared awareness with the people that are now engaged in that super system? In other words, would you consider that computing device to have consciousness?
Well, maybe I'm going to avoid the question, okay? So let me be transparent on that. But let me tell you what I think is changing. And I think what is changing is the very reductionist way of thinking about entities. And so the notion of the self and a person with a brain that thinks and the body that does is changing to understanding that actually the body thinks in way more complicated ways than just the brain. And we have in ourselves, I don't know how many bacteria and fungi and other entities. So where is the beginning of us and the end of us? I think modern science is challenging those notions.
Right.
And so I think the naive view that we have of a computer is this thing that I have in my hand and then everything else is not my computer has to change to computers that are more integrated. And we believe that methods of computing that use biological entities could be a really important part of that future. Fungal computers, slime computers, things like that, you know? So in that regard, those computers, yeah, you're right. Scientists are starting to think if those machines have consciousness. Again, I think the question of consciousness, that is a label that stops us. The point is you break that barrier and you open yourself to a completely new way of thinking about the interaction with technology and nature. Very important question, the question of consciousness. I think it distracts, at least me, it distracts me. And I think, Brandon, we have been talking a lot about this from a technology perspective because it's such a deep question, right? What is consciousness?
It's a deep question. All right, it's a very deep question. There are a lot of arguments one way or the other. But what I think we can instead talk about is with this new extended computing systems, whether they are biological or whether they're based on silicon or something else, they extend us and they create something new. And in that new system, there will be some emergent phenomena that we probably don't even know at this point we can think about.
Yeah, I think in the book we mentioned the analogy of sort of collective frontal cortex, so a reasoning system for the collective. Right. And I think the key that we've been describing is like, how do you do that in a way that preserves the meaning that emerges from those interactions and whatnot? So I agree.
No, thank you. Appreciate it.
So my mind is just blown with all the discussion right now. It's some excellent points being brought up. And I want to actually, go off to the point where in your book, you use a lot of analogies, because a central theme in your book is, of course, mathematical theory. And not all of us are, trained at graduate level mathematics. And you use excellent examples and analogies in medicine to describe composition. You actually also used learning from animals and how they are, going about their day, or how they set up their biological living conditions. So can you tell us why or how can biological systems teach us about system organization? And, are there any limitations to this analogy?
I love that question. And I want to build on what Esteban was describing earlier, because there's so much for us to learn from like the wisdom of nature and biological systems and the billions of years of evolution, that different entities have developed ways to live in harmony with one another and to develop these symbiotic relationships. And so I think that we can learn so much from thinking about how those distinct entities interact, yet become a whole ecosystem. How can we think about our organizations and societies as similar types of ecosystems? And how does nature structure and organize itself to have sort of that emergent harmonious way of working together? So we think that there's a lot to learn from there. And we talk a lot about biomimicry as a design principle, but we actually think that as part of our technology of the future, that we see nature as a technology itself. So how can we lean into that even more and harness the power of and the wisdom of nature? So that's something we think about quite often, and how to maintain the balance of the system.
I will add something to that, which is our machines kind of are separated. Even when in business, one of my favorite like separations or labels in business and in technology is this idea of hardware and software, digital and physical. And I think that has been very useful and has brought a lot of innovation and development to a lot of things. Like this call can be made because of that framework of thinking. But I think it's reaching its limits. And I think biological systems can help us, because when we talk about biological systems, we don't distinguish between hardware and software. We believe that in the future technology that we are describing, and in the context of mathematical reasoning, the distinction between that matter and patterns, kind of the symbolic world and the physical world, could be reconsidered, inspired by those biological systems, but also literally using those biological systems as one. Like if we use, for example, in the future, fungi to compute certain things, we don't need to distinguish between the software algorithm that the fungi is doing and the physical. Like we will never learn that level of detail about what is happening there, but we can use it as a system as one, and without that separation. So I think that's a technology trend that I think is preventing us in a way to move forward. We are so versed in the language of software and digital and physical, and we have so many terms for that are preventing us, again, are between our beginner's mind and seeing new things.
So you use the term beginner's mind, and my interpretation is just like looking at something from like as if obviously you've never seen it before. Is this the correct interpretation, or is there something more to share about this?
Well, I can tackle that one. I mean, I think, beginner's mind has a deep context in many philosophies, but the way in how we use it is the practice, the discipline, the craft of staying yourself open. And I think that is really, really easy to lose. I mean, you think about anything, like you want to start a new sport. Really, really quickly you become into the terms, you learn new things, hierarchies and processes. And I know skateboard, for example, you learn skateboard and the names of the parts of the thing, and
right.
The parks and how the different tricks are called and how different people who are famous are called, and the history of it, and your brain becomes so quickly entangled into what a skateboard is.
So it sort of becomes siloed, right? Your brain will become siloed.
Right. And so beginner's mind is more than an idea, is the reaction in the other direction, is the practice to be always saying, okay, great, that's very useful, but let me look at this thing like if I was looking at it for the first time. Let me look at the skateboard if that's the case, you will come up with new things, you will see problems that maybe others don't see, and so on.
And this actually flows very nicely into the next part, because I believe, like, looking at art with a beginner's mind, it's open to a whole new world of possibilities, and even relating to biological systems and looking at the patterns there, and translating that into art, it's such a whole new world. And so in your book, you have a quote: "Art offers an invitation to understand context." And Pablo Picasso famously said, "Every child is an artist. The problem is how to remain an artist once we grow up." So art in itself, it offers a glimpse of human history, and in return, we can obviously look towards the future. So no wonder one common activity whenever we go on vacation, we look for art museums, and just to get an understanding of a timeline. So why do you think that art is useful to technologists, or should be useful to technologists and engineers in understanding value? And do you really think that everyone should have some sort of art background in order to apply it to composition?
Well, thanks, Amanda. I personally feel very fortunate that when I went through school in undergrad to get my engineering degree, that it was from a liberal arts institution. And so as a consequence, I was taking, classes in art and humanities and philosophies. And I think that has really expanded my perception of things like value, and learning about abstraction, and seeing beyond tacit assumptions that we take for granted in a lot of cases. So, I mean, in my personal experience, it's been very beneficial as a way to just explore those ideas and learn more about representation in art, which is a common theme, and a way to explore myself. And we talked a lot about identity. So I think just in general, it's so valuable, especially for someone trained in engineering and those types of hard sciences, if you will. It's a useful way to really soften some of the sort of vexed ways that we think today about complexity and all those that come with it. So that's been my experience.
And in mine, I am very biased in this question, because I think it's fundamental to everyone involved in decision making or leadership or technology. I have a little daughter. If she was old enough to go to school and she was asking me, should I go to an MBA? I would say no, go to a master's in fine arts. I think you will learn so much more about technology and business, and in indirect ways, in abstract ways, of course, but ways of thinking that are so relevant for the future of technology and business. I think the tragedy, as we call it, is that our educational systems are, in most places, and this changes in different parts of the world, of course, but separating what they call STEM fields, the science, technology, engineering, and mathematics, kind of the productive fields, and the humanities and arts. Like, the other ones are kind of for people who just like to talk and think, and we think that's kind of tragedy number one. And then, just to answer the question directly, the tragedy is that we left people in the STEM field literally grow up without exposure to abstractions, to philosophical questions, to even history. And we see a lot of tragedies of the consequences of that in big decisions in technology and business and government and leadership. This is, to us, one of the causes of many malfunctions in organizations and innovation. So yeah, very important for us, Amanda.
Yeah, and it's interesting that you say, I like the term that you use. It's how art is so important in decision making, because I didn't think about it that way. But now that you explain it, I strongly believe that it's such a critical component of just trying to understand things.
So what important business or technology trends do you see in society today that change us as humans? Can you share any stories of products in development that fascinate you?
Well, thanks for the question, John. We see a lot of converging and exciting trends that have really inspired us to go for the next initiative after having written this book. One of them that we particularly are following is around the International Association of Electrical Engineers and their efforts to what they call reboot computing. So, we see experts in the world of computing challenging, Moore's law and what's next after the transistors and whatnot. So that's a trend that we keep our eye on as it relates to the technology that we want to develop. And we've touched on this a little bit, but we see a huge movement in embracing sort of natural systems and nature and regenerative leadership and circular economies. And so how do how do you think more as a collective in the commons and make sure they're thriving and balanced? And so those are a couple of trends that we see that we're keen to sort of put together and follow.
I will add a couple. I think an important one for our discussions with Brandon all the time is the idea of biodiversity. Recently, actually a few weeks ago, there was a big intergovernmental meetings, and I think it's called COP15, in where they came up and said, well, biodiversity should be a priority. And we think that biodiversity is starting to percolate into technology discussions in a way that we haven't seen before. It's really early on. But if you look at scientists like, I don't know, Neri Oxman at MIT, as Brandon was saying, trying new materials, new types of computers, new types of clothing that are biological and integrated in ways that we have never seen before, different footwear that is being created in this space, different types of sensors and so on. So I think that's a big trend for us. And on the negative side, I do think that what we call the post-personal computing era, I think it's really important to look around and see how depressing it is, the future of the personal computing. I think it's a future in where people are, addicted to these phones that are showing short, meaningless videos. And what is next is like even more videos, or this 3D version of there's no clear direction of a future that is more harmonic and inspiring. And I think that's a trend for us. It's an opportunity that opens the door for new thinking about the future.
It's really music to my ears to hear that, because I see the downsides that you're describing. Even in my own family, my daughter is struggling with a phone addiction, and she recognizes that it is self-defeating and that it is sort of she's self-sabotaging, using her words, by allowing herself to go down these rabbit holes and waste tremendous amount of time on them, and thereby disconnecting with human beings who are really the purpose of our lives, being in community with people. So I'm really grateful to hear you talk about that.
And John, if I can add something, this morning I mentioned at the beginning of this conversation that if I want to prepare for a fitness activity, I can download an app, right? So today is the actual Houston 5K, and tomorrow is the Houston Marathon. So I am running them both.
Oh my!
And I was preparing,
both?
So there is a thing called the triple challenge, and if you run both, they give you 3 medals. And so I signed up for both. And what happens is I download this app, but this was depressing to me. When I was in the App Store downloading the app to prepare for fitness, to run, the app also suggested me ways to modify the pictures of my body. So there's like all these. So basically the phone is telling me, hey, if you're running to lose weight, don't worry, you can just edit your pictures. You can just fake it. And
that's crazy.
That is bad on so many levels, because it is encouraging unrealistic expectations of yourself, because, oh, well, this is what I should look like, therefore I should do things to modify myself, rather than encouraging us to go to something that is more natural, more advantageous to us. It's like little girls thinking they need to look like supermodels.
Right. And the way we say it is a little different. We say it as technology is encouraging us to believe that our bodies and our physical reality is not necessary.
Oh,
so Zuckerberg's promise is you don't need to worry about reality. Just like pick the best of the best and live in fake palaces, in fake bodies, in a virtual world, in a meta world. That is depressing to us. We believe that technology should do the opposite. It's not about ideals and about standards, but about connecting to what is natural and real. And I think that the response from technologies and business to that statement is like, okay, that sounds good, but that doesn't sell. And we like them that they say that, because that is allowing for us to produce a lot of innovation and a lot of space for creating something new. It's like in the 70s, IBM saying that nobody wanted personal computers. So yeah, keep saying that. It's giving us the space to work in a new technology with more space and with less competition. So it's it's promising for us because, while many believe that there is actually not a commercial benefit of that, we believe that people like you, people like your daughter, people like me, and my daughter is 5, I am terrified of that conversation that you just told me.
Oh, yeah.
And I will work with Brandon. That's what we are doing to develop the technology of the future that does the reverse of that. So thank you for sharing that. Yeah.
So your daughter is 5, mine is 10. And I can tell you at 10 years old, that's when the whole awareness of the body and, what's popular, what's in starts to come in. At least from my experience with my 10-year-old. So I just saw a sudden shift between, 4th grade and 5th grade. And I'm still trying to wrap my head around it, like, where's my little baby?
Oh, yes. And that development period is critical. We have observed that in our children as well, that going from 4th to 5th grade, there's a lot more that's demanded of you. And it's a critical development period. And so it's very interesting. You're encouraging us to become a beginner again, or to enhance for us as people, as humanity, to enhance our ability to recapture that. I know from something just as practical as writing a user's manual that it is very hard to be a beginner a second time. So you use a piece of software. I have literally written a manual while testing a piece of software, but only by doing that could I really capture the point of view of the beginner and write a manual that might work for someone. Now, I think that technical writers can recapture that. They learn how to do it, but it's a challenging thing. But it also reminds me of some of the meditation that is being encouraged these days, the move toward mindfulness meditation, which some people might find as being a bit of hocus pocus, but taken in a positive context, that movement also tends to coincide with what you, Esteban, and Brandon are talking about. So, Esteban, I notice you're a martial arts practitioner, and I've done enough of that, not to the extent that you have, but I did some to be supportive of my son, who is much more heavily involved in it. And there is absolutely a meditative aspect of that. And it makes a lot of sense that you would also be doing martial arts alongside this development of ideas and of approaches that would allow us to become beginners again. But at the same time, we have to have old wisdom and we have to have new wisdom. I'm reminded of situations in which, let's just say, masters of a technology have reached the end of their ability to innovate, and they say, we can't make any progress on it. So we will give the problem to younger people who don't know what they can't do. And so then they're the ones who finally come up with a breakthrough that the old masters couldn't approach. Could you comment on that, both of you guys, a little bit, and bring that into what you're positing in your work?
Well, maybe I can start just because of the reference of martial arts. So you mentioned this conversation with your daughter about self-sabotage, and I always think about that because when I talk about martial arts with people that are not familiar, people frame it as a self-defense tool. It's like a lot of people think about martial arts as a mechanism to defend from something, or maybe it was created because of that. A few years ago, I actually started an academy, and it was called The Defense from the Self. We made a play with the words, and the craft and the discipline and the process of learning, I will say anything, but let's say a martial art, is a process of defending from the self-sabotage of our labels, of our ideas that constrain our thinking, our feeling of inadequacy, our feeling of, that the negative things that the world has around us are things to be pushed out, from our suffering, from all of those. And it's literally a process of introspection and in fight with the self. I mean, a lot of people say this in a very cliche way, but if you really believe it, it's quite profound. This idea, the enemy is within, right? And so I think that in that context, when you think about the technology in the book, we use the analogy of the digital mirror. So if you go to technology conferences today, they talk about the digital twin. digital twin is this idea that you can replicate something digitally, so you can play with it, make all the decisions, and see if they don't have risk, and then make the actual decision. So I, instead of deciding if I'm going to marry or not, I create a digital twin of me and my partner. I simulate the relationship. And I mean, if I think about it for more than 2 seconds, I don't know who wants to do that, because the fun is in the risk, the fun is in the uncertainty, the fun is in the trust and in the relationship that is built by doing that. So we instead are advocating for technology that is a mirror to the self, to the craft of self-sabotaging, to the relationship between ourselves presenting. And I think Mikhail talked about before about the avatar. The avatar, a lot of people think about it as an extension of the self, but we think it about as an opportunity to replicate ourselves by observing ourselves and by determining what is in there. So I think Brandon has a lot to say in this space, but the connection with martial arts for me is that constant reflection, that constant journey within that true masters have, right? I mean, every martial arts movie that is around those masters is about the journey within, right? So
yes,
I would just add briefly that we don't think there's a technology that exists that provides us that space that today, and that's, we want that place to be able to sit with the discomfort of trying to understand without trying to fix things, basically, to stay present to whatever it is, pain or whatnot, that the challenge of that honest contemplation and the hard work to examine the self and to look inward. So we want to be able to promote and progress technologies that help us stay open and to expand our circle of understanding and compassion for others. So
well, this is really eye-opening for me as well. In a sense, I'm coming to this conversation as a beginner because I haven't had the advantage of reading your book yet. I'm eager to do that now. But one of the things that really jumps out at me from this conversation we've been having is this notion of, let's not necessarily think in the classical Western way of a binary mind and body. Let's think of what is thought of as a more Eastern approach to there is harmony and completeness of mind and body together. And another aspect of that difference between what we do a lot in the Western world and what we attribute to Eastern thinking is jumping to conclusions. We love as Westerners to jump to conclusions before we have really allowed an observation to percolate within us. And what it seems to me that you're talking about, some of it is training ourselves, disciplining ourselves to not jump to the conclusions, but instead to remain open and to allow things to develop in our minds and combine with our minds and our collectives. In that context, I'd like to ask you, there's a question that we usually ask. I'm going to change it a little bit. We usually ask, what scientific and engineering breakthroughs do you anticipate? I'm going to say, what human, including perhaps scientific and engineering breakthroughs, do you anticipate in 50 years or 100 years or 200 years? And in that context, will humanity survive even in 200 years? So talk to me about some of those things that you foresee.
Well, I can start, and I think that this is a inspiring and personal question to us because we're dedicating our lives to leading the charge to really create some of those breakthroughs that we hope lead us to survival, to put it sort of in the, as you called it. And
right,
I think it's hard to separate the relationship between our humanity with technology and nature, but that's really where we see the coming together of all these things that we've been alluding to throughout the whole podcast and in the book. We talk about computing and new ways to think about that. The whole book's about, we talked about category theory very briefly, but advances in mathematics, advances in complexity science and systems theory, and we talked about economics and nature and all these things that really we think can come together and converge to get us out of this sort of paradigm of separation and boundaries and silos, and really get us to a place where the narrative becomes one of interconnection and interrelatedness and belonging, and that search for shared meaning for the collective. And how do you design a machine and technologies that can help us do that? So we want to lead the charge through our next venture to bring all these sciences together, the state of the art, the best minds in humanity has to offer, and put them in the same room and see what breakthroughs emerge. So that's really I think the contribution will be, the breakthrough will be bringing all those things together. And I think that's where we're trying to take it.
Yeah, and I think I will get back to the idea of, in the context of computer science, Claude Shannon was, I mean, he's one of the human beings that I admire the most. I mean, maybe the smartest person that I can think of. When he wrote this paper, A Theory of Information in the 40s, when he was at MIT, he laid the foundation for everything we have in digital technology. But he said information doesn't need to be meaningful. It can be only zeros and ones. Again, meaning is irrelevant to the engineering problem. And so one historical moment that I think is really important is when a few years later, when Shannon became a rock star, they actually changed the name of the paper from A Theory of Information to The Theory of Information. But I think Shannon was not silly when he said a theory. He said, keep it open. There are more options. I take that A as an invitation to challenge him. That's a true scientist. That's a true master. But I remember back to martial arts, in my black belt ceremony, my instructor told me, like, this is the beginning. This is like the black belt is the first step. And that shocked me because I worked so hard for that, you know?
Oh, yeah.
But I think we have to go back and change the name back of the paper from Claude Shannon and say, you know, it's time to revisit the theory of information. And it's time to revisit it with a major breakthrough. And that breakthrough is to put meaning in information theory, to put meaning as not just relevant to the engineering problem, but critical to the engineering problem. And how do we do that? Well, with languages like category theory. Category theory is capable of bringing meaning from the idea of binary to the idea of categories, a world that doesn't have to choose, but can contain it all. And that I think is the major breakthrough. For us, that's the title of the book, A Categorical Defense of the Future. We think that kind of thinking is what is needed to break through. So,
well, this kind of leads, since we've been talking about the future, to a classic question that we love, even though it's, well, actually, because it's audacious. Imagine you're taking an imaginary trip into the future or the past. First, do you think that actual time travel is possible?
I think it's ironic that we get a yes or no question at the end. And I will sidestep it and just, I remembered a passage from our book, actually, where we talk about this a little bit and say that our past, present, and future are all composed. And we're not passengers on some metaphorical train that moves through time. We are time. And that means we have a responsibility to show up in every moment. So I would say that that's my response.
Esteban?
Well, just to cover the second part of the question, like when I imagine the future, I do imagine a future that is more integrated to nature. Plants are not just decorative. Our gardens are not just things that we maintain for looking pretty. Our bodies are all considered part of our awareness and intelligence, not just our brains. And the collective and the science of the collective is progress with new machines that can help us reason in ways that are more efficient. I imagine a future in where we embrace that reality and that connection. And that happens from the computer. One more story about my daughter. We were in a meeting with Brandon talking about this new computer, and she overheard me. And she said, what is this CAD computer? And I said, well, it's a computer made of water. It can be made of water, you know? And she went to school, and then next day she was like, I was looking at water, and I was thinking, like, how can a computer be made of water? And I think that is already showing how this can connect you to observe, to touch, to ground yourself. Of course, mobility and the changing of geographical positions because of the way in how we work and the way in how we interact is going to play a major role, I think, in how land is used and resources are used, and that will help envision new mechanisms for interacting with the land and with the water and with the organisms around us. And so I think that is going to enable mechanisms of computation that are not necessarily easy to see right now because we have so much cement all over us.
Yes.
And infrastructure that is dead. And we will be able to see our cities and our context more alive.
That is an awesome future vision to just try to get our minds around. It's very, very inspirational to me. Now, taking another jump into imagination, let's say it was possible, literally, to do some time travel. Where in time or when in time would you want to jump? And why? Would you want to jump forward or backward? How far? What are some of the things that you would want to see in that kind of experience?
Maybe let me start with that one. I think a lot of the experiences and thoughts that we describe, John, in the book and in this conversation come from a lot of suffering, a lot of real experiences. I would like to come back to those moments that I miss, because I think in that there is the appreciation of the present, of what we can do for the future and for the ones that are around us. So I think it's maybe not the answer that you're expecting. Of course, I would like to meet Alan Turing in person and envision how he will design a computer now. But I don't know. I will go back and meet with my dad.
Right.
I love that. I was thinking more along the lines what you were saying about Turing, Esteban, and Esteban and I often have this thought exercise of what if Steve Jobs never invented the personal computer, or Apple didn't become the juggernaut, and this narrow focus on personal computing as an extension of the self. What if that wasn't the way? We see it as, it's so easy to celebrate it and see it as a good thing and advancement, but I think just it would be interesting to see if that didn't happen, what would have emerged instead of the personal computer. So I was thinking about that conversation, seeing that moment in time.
Well, there are so many branches of this conversation, this group conversation, that we could take. We could go on literally for hours, but obviously that's not the approach of a podcast. You can't summarize everything, but still, what are some of the things that you would want our listeners to remember, just a couple of sentences each, on what we've discussed today and where you think we're going? If each of you could say a few closing remarks. They don't have to be ultra short, because of what we mentioned before, that you can talk about your next efforts as well. But go ahead and frame something as a kind of a closing remark with hints to the future.
I would just say that we are just grateful, first of all, for the opportunity to join you all on the podcast. So thank you again for having us. And we're excited about the next phase of the project. So look out for the company, the technology that we're going to be developing, the categorical computer. Yeah, I will let Esteban take us home.
Yeah, I was going to say the same. I think podcasts and people like you that are thinking about the future in such an unconstrained way are very rare. A lot of people want to talk about what is hot and new. I'm delighted that you didn't ask me for my opinion on ChatGPT or what we call TikTok technologies. I'm very happy that there is a space and people like you and your podcast that allows us to think without constraints. So thank you for that. And that would be my invitation to the listeners. I think these spaces are actually rare to find. And if they were lucky enough to find it, I will share it with others. But I will figure out what brought me here. And I will try to find more Johns and Amandas and Mikhail, because as I said, to me, in my experience, you guys are rare, a precious entity. So I will make an effort to find more of these and to encourage and support and appreciate what you're doing publicly. I think I understand podcasts leave a lot from reviews and from feedback. I will encourage them to do that. That's how you take action and leadership. You find something good and you support it and nourish it to grow.
We will try to live up to your hopes and ours as well. Amanda, unless you have anything to add, I'm going to go ahead and stop recording.
Do they want to add where email addresses or contact information?
Oh, yes. So go ahead and tell the audience how to find you if you want to be found, and also what some of the links are to your current work and where you're going.
Sure. You can always reach out to us. We each have LinkedIns. You can find our names there, but also emails, Brandon@categoricalfuture.com and Esteban@categoricalfuture. And also our website for the book, which has sort of the background and what we're up to, is categoricalfuture.com. So those would be great resources, and we're always open to connecting.
Fantastic. Thank you for listening to this episode of Vision 2222. And if you enjoyed what you heard, please subscribe, like, and share with your friends. Please also comment, and we'll do our best to respond.